Every day, millions of workers around the world face more than just tasks and deadlines. They confront real dangers, the kind that can change lives in an instant. Every year, inadequate safety measures and hazardous work environments claim the lives of millions. The cost is immense, the loss irreversible. But the impact doesn't end there. As industries adopt rapidly advancing technologies, new safety risks are created, with a disproportionate effect on many parts of the world, where safety laws barely reach 10% of the workforce. However, there is hope. Advanced technologies can be harnessed to address both new and existing safety challenges. From AI-powered monitoring systems and smart sensors that predict equipment malfunctions to drones that inspect hard-to-reach places. Safety is a fundamental human right and should be central to how we develop and deploy technology. Global collaboration and knowledge sharing are essential between industry and innovators to ensure that safety needs are addressed worldwide. This is why the Global Initiative for Industrial Safety has brought together the United Nations Industrial Development Organization, Lloyd's Register Foundation, the Global Manufacturing and Industrialization Summit, and Cambridge Industrial Innovation Policy to launch the Manifesto for Global Industrial Safety, a movement set to achieve a safer world enabled by technology. This manifesto is the first of its kind, a set of industry principles dedicated to integrating advanced technology with safety protocols to address the challenges of Industry 4.0 and beyond. The manifesto aims to establish universal safety standards that promise not just compliance, but a renewed commitment to a safer, more sustainable industrial future. Join us in supporting the manifesto on our website to pioneer a safer and more secure world.
Hello, good afternoon, everybody, and what a great video. What a great way to start the webinar. Thank you so much for connecting today. My name is Carlos López-Gómez. I am the head of the Policy Links team, which is based at the Institute for Manufacturing at Cambridge University. Just to begin, we strongly encourage you to participate in today's webinar. You can submit your questions. You can see at the bottom of your screen in the Zoom box, you have a Q&A function. So please continue to send your questions there. Today's session is being recorded, and you will receive a link to the recording in your inbox later today. Today, the main objective of the webinar is to talk about the Manifesto for Global Industrial Safety, which outlines a set of guiding principles to promote the safe adoption of new technologies in industry. First, I will take 10 minutes to go through the manifesto quickly, just to tell you a little bit about the principles in the manifesto. And then I will be joined by an excellent panel of experts to talk more about the manifesto. So it will be a quick presentation, and we're going to focus on the discussion. And then we're going to be picking up your questions from the Q&A box and try to address them as well. So I'll first start by sharing some slides with you. I think you can see my slides now. We're sharing some slides now. Sorry for the... Thank you so much. Let me just...
Sorry, you need to.
Thank you, Katie. In 2017, a cyber attack targeting a petrochemical facility was designed to undermine safety systems controlling critical processes. Researchers found that under the right circumstances, this could have resulted in considerable physical destruction across the whole facility. One minute, please. I'll stop share. I'll share again. Yep. Thank you, Katie. Sorry for that. Shortly later, a study found that an attack on a chemical plant, which tried to tamper with sensor data for a pressure vessel, could have resulted in an explosion and caused not only physical asset damage, but also injury or death to employees. These are just two examples of the huge safety challenge that the world faces. Every year, the International Labour Organization estimates that around 2.9 million deaths are attributed directly to hazardous work environments. To give you a sense of the scale, this is more than the total number of COVID-19 deaths reported in the world in 2020, at the height of the pandemic. Work-related safety incidents result in the loss of approximately 4% of worldwide GDP every year. All this affects developing countries disproportionately, where only 10% of the population are covered by safety laws. So there is a moral as well as an economic imperative to tackle this global safety challenge head-on and on a global scale. Now, you might ask, well, safety has always been there since as long as people have been employed in workplaces. But today, the reason why this initiative, we believe, is so timely is that there is a new variable, and that is technology. In particular, a number of technologies such as Internet of Things, artificial intelligence, and robotics are becoming cheaper, easier to use, and widely accessible. These technologies allow us to have smarter products, more intelligent factories, more flexible supply chains, all very good things. But as industries integrate these technologies, the global safety needs are evolving. How do we make sure that as we use these automated guided vehicles in our warehouses or in our factories, transporting parts across, how do we know that they will avoid physical risks to workers? How do we certify these algorithms that underpin artificial intelligence, which are highly complex, not always transparent, prioritize worker safety? How can we ensure that digital devices used to supervise workers do not lead to negative stress-related or the so-called psychosocial health impacts? So with all this in mind, the United Nations Industrial Development Organization, UNIDO, the Locke Register Foundation, the Global Manufacturing and Industrialization Summit, and our team of Cambridge Industrial Innovation Policy here at the Institute for Manufacturing have come together to create the Global Initiative for Industrial Safety. The initiative recognizes that, yes, on one hand, the technologies involve new challenges, but also we need to think about the new solutions. Drones are helping us conduct hazardous inspections in high altitude without needing to expose a worker. Advanced sensors and analytics are being used to predict failure and more precisely know when machinery needs to be maintained. Virtual reality and head-mounted displays are helping firms provide employees working in risk-prone areas step-by-step instructions using the correct tools and parts. Now, the first flagship output of this initiative is the Manifesto for Global Industrial Safety that you have here in front of you. Our teams have worked with experts from industry, academia, regulatory bodies, and governments to develop the Manifesto, which outlines a set of principles for the safe implementation of emerging technologies within industry. These are the goals of the Manifesto: to promote the safe adoption of technology in industry and the use of technology-enabled safety solutions, anticipate emerging safety risks, and disseminate real-life examples for addressing them, and highlight opportunities to support developing countries disproportionately affected by workplace accidents. I think one important thing to highlight here is that the approach that we're taking is to make sure that we communicate to all the stakeholders that safety is not just this typical hassle, a boring area, but it's actually, thanks to technology, becoming something exciting. We can use these new technologies to tackle a global problem. And it's exciting for both safety practitioners, but also for those interested in technology and hopefully young people as well. Now, the manifesto has 5 principles, and I'll go quickly through the 5 of them. The first one is uphold the human right to safe working conditions. Principle number 1. What does it mean? In June 2022, the International Labour Organization added the principle of safe and healthy working environment to its fundamental principles and rights at work. Until now, there had only been 4 fundamental principles, but this decision of the International Labour Organization means that occupational safety and health will become the 5th category, so a human right. The manifesto therefore sets an overarching expectation that the global industrial community should embrace a renewed commitment to deliver a safe and healthy working environment as a fundamental human right, making emphasis on the role that technology can play in this process. It also calls for actionable safety plans to improve safety in the workplaces and leveraging technology not just for recovery when something bad happens, but also for prevention, preparedness, and response. Principle number 2, ensure safety is central to technology decisions. So this principle encourages companies to ensure that safety is at the core of all technology investments. Stakeholders should take steps to identify and respond to new risks associated with novel technologies and their applications. And here, we pay particular attention to new sources of psychosocial risks that could affect the mental well-being of workers. It is imperative to identify new cyber, physical, and psychosocial risks from new technologies and reflect them in company policies and procedures, job instruction sheets, and day-to-day operation. Now, the third principle is exploit new technology enable safety solutions. And again, this is the exciting part as well that we would like to emphasize, that technology can be seen as a solution to these all safety risks that we had in legacy industries, in legacy operations, but also thinking about the new risks that come across when applying new technologies. There are already some well-known technology solutions to existing problems, but we need to increase awareness and develop new skills in order to deploy them globally. So overall, this principle highlights that safety, again, is not an afterthought. It's not something that we should think as a boring thing, but it can be an exciting technology field with a huge impact in the world. Now, fourth principle is share, monitor, and promote safety lessons. This principle requires the development of a new culture of monitoring and data sharing. Many organizations, for good reasons, are hesitant about sharing safety-related information, but opportunities exist to collaborate in a pre-competitive manner. This principle is about encouraging organizations to commit to building safety knowledge by sharing lessons learned and near misses, as well as best practice data and tools. So a key part of this is to develop and adopt coherent global metrics and encourage continuous and consistent benchmarking of safety practices. Now, number 5, I think I've mentioned already the importance of thinking about developing countries in this context. While we understand that the safety challenge and the safety rights are universal, developing countries are affected disproportionately by safety issues. So just to give you a sense, Asia and Pacific account for over 60% of global work-related mortality. So many countries still lack strong legislation frameworks and the know-how and infrastructure to implement it. So this calls for companies, governments, and civil society to join efforts to continuously and systematically support safety efforts in developing countries so no one is left behind. So again, these are the 5 leading principles. We invite you to learn more, to download the manifesto, to learn more. We also invite you to endorse the manifesto. We want to create this community of the willing, if you wish, community of organizations that care about industrial safety. We think that your organizations can get a lot from being part of these organizations, so really contributing to global impact, but also gain visibility and recognition. We will be showcasing some case stories about how your organizations are using technology to tackle safety solutions. So we really encourage you to send us your case stories so we can promote them as well. And we are creating this global community of practice. So just finally to say that please download the manifesto using this QR code on your screen, or just go to this website, industrialsafetyinitiative.com. And if you have an interesting case story, please send it to this email, and we will be happy to talk to you about showcasing your efforts. So now I'm going to stop sharing my screen, and I would like to welcome our 3 fantastic panelists. Really happy to have them here today. They've been supporting this initiative from the very beginning. And first, we have Kate Field, Global Head of Human and Social Sustainability at the British Standard Institution, BSI. Sebastian Corby, Principal Consultant at SafetyTech Accelerator. And Michael Tooma, Head of Environmental, Social, and Governance at Hamilton Locke. Welcome, everybody. Thank you so much for taking the time. I've talked a little bit about the principles very briefly. So I would like to start perhaps asking you guys, what principle would you highlight? Which one is more important to the kind of work that you're doing? And which one do you think we need to be thinking more for tackling the safety challenge that we have in front of us? So if I could start with you, Kate, any immediate reactions?
It's a really tough call. There are 5 principles because there are 5 principles that we need to help and support organizations and developing countries with. So narrowing it down, I think if organizations follow the 4 principles, and obviously the 5th is about how we strengthen and support developing countries, but I think if organizations look at the 4 principles and think about how they can apply them to their own organizations, they're going to be in a really, really strong space. But the question you asked me, which is tough, was where would I go? I can't ignore the very first principle, which is safety as a fundamental right. I mean, that is the fundamental, the grounding principle. You know, it's been there as long as organizations have really been existing and offering employment. And I think it's fantastic that the ILO has strengthened that fundamental right by including it in their list. And if we embrace that, it will really drive change across the world, and particularly with developing organizations. The one that speaks most to me, and kind of where I come from and what I'm passionate about, beyond the principle of fundamental right of health and safety, is principle 2. And it's not just because 2 is my lucky number, by the way. Principle 2 for me talks to designing in safety. You know, I think one of the challenges that we often have is that health and safety is an afterthought. A decision has been made about a piece of equipment or building a building, a structure, or coming up with a new process, and it's all done and dusted, and then people start operating or working in the building or using the technology, and then they start to realize actually there might be health and safety issues. You know, but the new machine might be noisy, it might have high vibration. If it's software, it might be ergonomically difficult to use, high click rate on a mouse, or whatever it happens to be. And actually, if we stop and we pause and we think about what are the health and safety implications at the point we start thinking about something new, then we can design in and address health and safety issues before they become a problem. You know, there's really good studies, particularly in the built environment, that show that if you have to go in and correct an issue after the building has been constructed, it costs significantly more. I mean, you know, quite often millions, you know, significantly more than if you'd actually just addressed it at the point of design. So for me, I think it's principle 2 because it's designing in, and as a core part of that is really that human-centric approach, and not just thinking about physical safety, but actually, you know, when we start to think about some of this technology, you know, the psychosocial risks, the mental health implications, and I think that's really critical.
Thank you so much, Katie. That makes a lot of sense. Seb, if I could bring you in, the SafetyTech Accelerator, I guess you guys are really close to implementation. You really have your feet on the ground, thinking about how to deploy technologies for safety purposes. So you've seen a lot of this working in practice. So can I ask you just the same question? What would you highlight and what speaks to your work more closely from the principles?
I think 2 is really important. One of the things that I guess frustrates me is that sometimes people look at the concept of safety technology and they look at a kind of maybe a camera that detects someone falling over, and that, you know, camera detects us falling over, problem solved. And it's quite a kind of confined ecosystem of technology safety problem. But I think the reality is that the biggest steps forward in safety and technology are actually when you look at the kind of wider digital transformation programs that companies might go through, where safety results from just being better at what you do, more efficient, more productive. You don't just remove an individual from a risky environment for the safety outcome, but you also do it for a host of other outcomes. So the concept of safety tech, not just being a widget that someone's selling, but a kind of philosophy that actually is embedded across all of your investment decisions, I think is really important. And it's good to see it worded in the way that it is there, because it means that it can form a part of a wide range of different applications. But as that one was also chosen, I think number 5, like the idea of supporting improvements in developing countries, is very interesting. I think one of the challenges with emerging technology, especially emerging technology in practical environments, is it's very difficult, it's very complex, it's a highly regulated environment. There's lots of things to go wrong. It's very difficult to collect data. And what that means is that we have to be experimenting, we have to be trying things, we have to be working together. And developing countries can't afford the failure, but I think we can. So we need to make sure that we kind of do the groundwork, whether it's working out what technology works, identifying points of failure within situations that we've only learned about from experience. I think we need to make sure that we transfer our knowledge and learnings to developing countries, because they can't afford to go through the same process of trial and error, because they don't have the funds and resources to do so. And I think it's a gap for us at the moment. How do we transfer knowledge and learning to developing countries from countries that have gone through the research and development and the learning and the failure, so that they can hit the ground running?
Thanks, Seb. I think we're going to go back to this point of developing countries in a second. But can I just turn to you, Michael? I mean, you've seen this initiative from, I guess, a couple of years already. You've been in the workshops, you talked to a lot of people, and yeah, you know more about these principles than anyone else. So difficult for you to pick, but can you tell us what's your favorite?
Yeah, I feel like I'm in the same dilemma as Kate, picking between children. But of course, all 5 principles are exceptionally important. They're interdependent and overlap in many respects. I'm going to focus on one that speaks mostly to me, and that is the 3rd principle. And I see, and I really note what Kate said in relation to principle 2, because that is so important to build, safety by design and technology. And I agree with everything that has been said in relation to that. But I'm really excited about the possibility of actually deploying technology to eliminate hazardous work, as is now being done on a regular basis across industries. Whether by using drones to do hazardous welding in off-rig shores, as Chevron's doing, whether it is using robotics for firefighting, whether it is using remote equipment to do work that would otherwise be at heights or in underground or in difficult environments, eliminating having to do inspections, and particularly in an industry that I do a lot of work in, which is electricity transmission, where traditionally people would need to work at heights to inspect infrastructure. That work now being done by drones, eliminating a lot of the working at height work that is required in that space. And in addition to those type of activities, which are about introducing technology to accelerate the improvements in safety, you also get the opportunity to deploy technology for the design of systems to improve safety, both in terms of data analytics. I was doing some work, today with a consultant that rightly asked whether they could deploy AI for a major risk assessment that we're undertaking for one of my clients. So prevalent is the use of technology that the consultants are deploying it to, not as an alternative to expertise, but to enhance expertise and the quality of the work that is being deployed. And I'm really excited about those type of solutions then being communicated and shared under Principle 4 in terms of sharing information, sharing learning, having case studies shared in a broader community, and really commend this this work that that has been done around the Manifesto as providing a global framework for that community to be created, for that further investment in technology to occur.
Thank you, Michael. And I think that that's a perfect segue for the next question. Now you're talking already about real world implementation. Seth, if I could turn to you, perhaps we've been discussing this in a way in an abstract manner, but could you share some examples of particular technologies and how they are being used to tackle safety issues, either particular solutions, particular companies? Just in simple terms, how are these technologies being used?
Yeah, I could probably talk all day about this. But to my kind of previous point, like for me, the most interesting safety technologies are actually the application of more general, highly capable technologies within a situation that breeds a really positive safety outcome. So you might not see safety on the website, but actually what you've done is brought together really cutting edge technologies. On the kind of drones front, I think we all feel that kind of drones have been around for a long time, but the reality is we're kind of only really starting to push them into the environments where they should be now, and there's a lot of reasons why they probably aren't, more widely used, but I think we're starting to see them be used. We had a really effective pilot with a mining company. I can't kind of talk about too many specifics, but the situation was that the mining company was getting a lot of injuries and deaths as well from loose rock at the top of a cavity after a blast had cleared the rock face. There's a lot of loose rock that sits up there, and the method that they employed to remove it was an individual would go in with a kind of 6-foot rod and tap the ceiling, and rock would fall down. And it's not difficult to see how that might not be the safest thing to be doing, but it's also quite tricky to find an alternative. So we explored a lot of different things, and one of the things we need to do is we kind of need to remove the need to actually remove the rock manually, but we also need to find out where the rock is loose, because you can't just go and tap the entire cavity. One of the ways in which the human being would find out that rock was loose is that they'd listen to the sound of the pole on the ceiling, hear that it was loose, and then they'd scrape it down. So we brought together a number of different technologies. Firstly, drones that were configured for confined spaces, and the drone was set up with both a LiDAR scanner to create a model of the cavity, but also a thermography camera. And what we found was actually that mapping the rock face using LiDAR and infrared thermography, you're able to identify quite small changes in temperature, which would then suggest that there was a greater risk of loose rock within a given area. So the drone would enter the mine after the blast had taken place, but an hour before people would enter. It would map the mine using thermography. It would use machine vision to actually identify and learn areas that were looser and less loose from the thermography and LiDAR imaging. And then we looked at a wheeled drone, which had a lance attached to it that would then visit the areas of high risk and would shoot the lance at the ceiling, and would actually then process microphone data that would again use AI to understand whether the tap of the lance on the ceiling was generating a tap that was that, you know, indicated loose rock and almost mimicking the human. And at that point, you could then actually bar down using the remote tracked drone. So it was a kind of wholesale replacement of human beings within a highly risky environment with 2 forms of drones, with 2 or 3, you know, AI engines, multiple sensors, and, you know, not one of those companies on their website, well, not only, I think some of it required product development, but, you know, you're not Googling kind of mining safety technology. What you're doing is starting with a really fundamental problem, and you're bringing together a number of different advanced technologies to work together. I'll give one more example. We also do a lot of work in maritime, and I think the concept of collecting data through sensors and being able to process that data effectively, and you know, one might call it AI, another person might just call it really complex statistics. You know, I'll leave that debate for someone else. But the point is, we've got to collect data, we've got to collect it quickly, and it's got to be high quality. But to do the really fancy stuff, we've got to be able to process it in a way that can affect a decision that is useful for us. So we're also tackling fire detection on container ships. It's something that's a big issue for us, but it's also an issue within manufacturing, any warehousing, logistics. One of the issues is that on a container ship, there's kind of 1 million containers. One of them might catch fire, and then depending on what's next to it, the fire will, you know, propagate at different speeds. The current detection technology is smoke. Air is extracted every half an hour through an exhaust system, and smoke is then analyzed through an optical sensor in a central fire control unit. It's super slow. It's been around for 60 years. We looked at thermal imaging, we looked at air temperature sensing, but by the time that you've waited for the container to heat up, you're still quite far down the line of the life cycle of the fire. So we are working with a very small startup that has developed nanotechnology e-noses. So this is where a number of nanotubes are placed on a microchip, and depending on the nature of the elements, like within the air, that are ingested by the nanotubes, that generates a signal, because it effectively kind of changes the amplitude and the transaction of electricity within the nanotubes. So if you expose the nanotubes to, I don't know, a rubbish tip, it will generate a certain signature. And if you expose the nanotubes to loads of hydrogen, it will generate a certain signature. And what the signature then does is then sent to a local processing storage unit, which then starts to generate a graph and a map of the various signatures coming from the air. So what we can do is we can actually expose the chips to the smells and environments that we care about and that we're looking for, and we can use artificial intelligence to then learn what that specific signature is. So it's got 32 channels. Each of those channels responds differently. So each smell generates a unique 32 channel signature. We train the chip and the AI model behind it, and we then put the sensor, for example, within an engine control room on a container ship. We've trained it to detect heavy fuel oil. And now actually, when heavy fuel oil is spilt within the engine room, which is a really high risk, not just of fire, but of other things, the sensor can alert us to heavy fuel oil. So it's a really novel way of detecting gases and environments with locally, compared to what typically you have is for around 100 years you've had traditional gas sensors. More recently, you've got IoT multi-chips, which have got a lot of different VOC in particulate and gas sensors on them. But this is flipping it on its head and using nanotech and AI to actually say, well, we can smell anything. So that I'll leave it there. But those two examples of where you're not buying safety tech, you're exploring how really advanced technologies can provide kind of wholesale changes.
That is a great way to put it, right? Like the problem, the safety problem, and how it can bring solutions, technology solutions, to solve them. I think those are great examples. And Michael, you already talked a little bit about using data analytics and how some of your clients use it for design. But what successful applications have you seen being deployed in the field?
Yeah, I mean, given the nature of my work, I often get to work with clients in relation to remediation projects after incidents have taken place, typically fatalities. And sometimes those are overseen by regulators, and sometimes they're just at the initiative of the company itself. So I'll use a couple of examples from that experience, and since Seb's spoken about mining, I'll talk about sort of some other industries, particularly in the logistics and warehousing space. One of the biggest issues that people in that industry face is interaction of mobile plant, particularly forklifts, with people. And the traditional way of trying to address that is to have segregation of mobile plant from people through protected walkways and keeping people away from forklift operations, which is absolutely the right way to go about it, and a viable way for the most part. But still unexpected things happen, particularly where you have people come onto the site to do deliveries, or truck drivers, and they need to come off their truck, and then someone offloads their truck. So as a result of a particular incident, one of the organizations that I work with has deployed a solution that really heavily relies on AI and sensors to try and actually create and enforce the exclusion zone around the forklifts themselves, by having wearables on staff and people that come onto the site, by putting it on their high visibility vests, and then having the forklifts themselves unable to scan and detect those wearables, and then once someone is detected within the exclusion zone, to actually immobilize the forklift itself, and means that it alarms and stops at that point in time. So it actually enforces the fundamental safety principle of segregation of people from the area where they can be harmed by mobile plant. I mentioned in my earlier sort of comments what I find exciting, which is the deployment of AI, in particular in relation to analytics. And again, in the same sort of vein, we're involved in a couple of projects where that is occurring, and one in particular where CCTV footage is being used to detect instances where there might have been a near miss. The thinking behind that is that although incidents are typically reported within organizations, near misses are perceived sometimes not to be as important, but actually from a safety perspective, from a safety principles perspective, there are not only as important, sometimes even more important, because there can be lead indicators of future more serious incidents, particularly if they are repeated. They can tell you a great deal about what is not working, and what might lead one day to a more serious issue. And so by deploying AI to scan CCTV footage and actually flag instances where there might have been an near miss, quite a simple combination of old technology and new technology, but actually deployed in the right way, can really enhance a health and safety professionals' insight and work into what is going on in their organization, and can be quite a powerful tool.
That's great, Michael. Thank you so much. Really interesting. Many people are complaining about forklifts in warehouses as well for manufacturing and how often the accidents happen there. So I think the example you gave is really interesting. Kate, can I ask you the same question? Some exciting technology and how it's been used?
Yeah, I mean, there are so many examples, and you've heard brilliant ones from Seb and Michael. I think there's probably two elements that I'd like to highlight, and I suppose it's building on from Seb's point about start with the problem. And I think one of the I think and thinking about what I said in terms of what's my which principle I choose, which is two around design and designing in. And I think digital twins are one of the most exciting tools that we have, particularly when they're used as 3D digital twins or over 4D. So 4D is when you're looking at the, and it can be an item, a product, it can be a process, it can be a whole building infrastructure project that you can apply digital twin technology to, and 4D is when you apply it over time. So you see what that looks like. I think is one of the most exciting opportunities that we have, because a digital twin allows you to see the issues before they happen and solve them. So designing in safety. And I think, I've seen some really amazing use cases of that. And I think one of the things that's most exciting about it, if it's used well, is it talks to principle 4 about collaboration. So I've seen it being used really, really effectively, where, the people who kind of use the technology have designed the digital twin, but then they've shared it with the workforce or with a particular team who will need to be involved in a particular aspect of the project. So a good example was, there was a point at which the foundations for a very complex building site needed to be put in, and that was going to be used by using a crane, in simple terms. And they created the digital twin of the site and where the crane would be. And they started to look at different scenarios about what the crane would need to do, how it would need to move, and what the risks were. And they had the crane operators and the site operators there, and they were able to identify particular challenges and issues. And the thing was, what was really powerful about that example was not only did it address the safety risks, the solutions they came up with made the project far more effective. So actually they'd allowed something like 6 weeks. By doing this work on the digital twin, they actually completed the work in half that, something like 3 weeks. So I think there are real opportunities for using digital twins. And I think, that's a technology that's much more accessible maybe than people think. And I think the other aspect of that that's exciting is, and again, it comes back to that problem solving, is it pulls together cross-functional teams. So, I think sometimes, it all happens to all of us, we get blinkered, we see a problem through a single lens. And if we can pull together different cross-functional teams, I think that becomes really powerful. And I think for particularly developing countries, if they pull in expertise or insight from other industries, which can be quite easy and cost effective to do, that your next door neighbor who might be making something else or doing a different job, you say, I've got this challenge, what do you see? Can be really, really effective. So, seeing that again on a bigger scale, but the construction industry reaching out to the Formula One industry to look at the way they manage risk. So I think if we can explore those opportunities, it doesn't have to all be about the technology. Sometimes it can just be about how can we learn differently.
Now that's a great point. I think we made also the emphasis on the manifesto about you don't compete on safety. You can actually collaborate pre-competitively from different industries as well. So those are great examples. And I think I'll turn to you, Michael, on this point. You already mentioned this issue of wearables and how people are using to monitor risk areas, but also at the end of the day, we monitor people. And that brings us to think about the challenges to implementation, including as people are using these cameras to monitor work areas, more people are getting stressed. So the psychosocial challenges. So what other challenges you see in the field that prevent companies from implementation?
Yeah, I think that they're excellent sort of points that you're raising, Carlos. And the issue really is that there's a genuine concern as we roll out and adopt new technology, and that has been the case always with new technology, that it creates both ethical, social, and additional risks that hadn't been contemplated by existing users. And on the social aspect, privacy is a real concern, because the more that we enable the technology to collect data, the more that we analyze the data, the more that we are invading people's sort of privacy, and so some parameters and restrictions in relation to that use to deploy it for its proper purpose, rather than abuse it and use it for discipline or other reasons. Those guardrails become crucially important in terms of how you frame some of those solutions, but also thinking through the risk assessments and the unintended consequences of some of the technology as it evolves. So two areas of concern that I have. One is sort of in the medium term, as we move from an old world or existing position, the status quo, to a future world of greater automation, whether that is the Internet of Things or just generally automation, and greater use of technology. There will still be occasions where the old systems and the new systems will coexist, particularly where there needs to be some maintenance or the like being done, and it's actually thinking through what risks arise from that context that become crucially important in relation to ensuring that we're not creating risks that haven't been considered. I'll give you a couple of simple examples. If you take out a large proportion of the manual workforce and deploy it for other purposes, and so you have less workers doing work in a more automated environment, then some of that work that was just work being done in a normal working environment becomes remote work all of a sudden, because you have one person sort of running around in an environment where there might not be other workers nearby, and actually ensuring that you have proper systems in place in relation to managing now the unique risks of remote work become crucially important. Nothing new about remote work, but these are things that did not used to be remote work, now are, because we've changed the working environment considerably. And then in the same sort of vein, there is good reason why one should move to autonomous vehicles and also electrical vehicles, but we know electrical vehicles are incredibly quiet, for example, as opposed to motored diesel or petrol vehicles, and so the normal instincts of hearing and not just seeing is less of a natural protection, and so you need to retrain people and create some systems around that. And then, in the same vein, lithium batteries, the way you respond to lithium batteries in an emergency is different to how you respond to other vehicles. And then one last point, since I have spent a lot of time focusing on AI, which I'm very excited about, AI hallucination is a big challenge. And AI hallucination, which is where artificial intelligence can't find an answer and then is creative in actually creating that answer. And there have been a couple of famous examples in court cases where cases have been made up by AI and presented to judges as if they're real because of reliance on artificial intelligence and research. Well, that can have more than just embarrassing consequences as occurred in that context. If one is relying on it for the risk controls, for a HACCP, for something of some material importance, without the checks and balances of experts supporting that, that can have tremendous consequences. And so again, guardrails and protections and quality control becomes crucial. Nothing new about any of that. Nothing new about anything that I've said, and they're not insurmountable problems, but we need to think them through and then work through those controls.
Thank you, Michael. That's a great point. And we only have 5 minutes left for the webinar. Thank you to those who are sending questions. Please, if you can share your questions, we're going to take a note. But there is a question just immediate here, just throwing through you guys. It is about the design of a manufacturing plant that uses process hazard analysis to identify risks. So can the panelists share an example of how AI can help to improve design of manufacturing plants to eliminate safety risks? And you already mentioned something there, Kate, on digital twins, of course. But I don't know if anyone has any other views on this. How do we use AI to improve design of manufacturing plants to eliminate safety risks? Seb, do you want to comment?
It's tricky, quite a broad question.
Yeah.
I think if you look at something like, at least with a manufacturing plant, it's going to be static, or maybe it won't be. Maybe it won't be completely static. But if you look at something like flexible robotics, robots that are doing multiple things, it's very difficult to regulate and identify the critical safety interactions that they might have, because you might design one where the robot is moving up and down, and that's okay. But then what about when the robot is doing something else? And if you begin to add more complex variable systems, the potential for risk increases, but your ability to understand those interactions decreases kind of exponentially. So I think AI has a role to play in helping us model the different scenarios which flexible systems that are doing multiple things, systems that have multiple points of failure, both in terms of a system, I'm just thinking from a spatial perspective, but also chronologically, systems that are doing different things at different times. And I think from a manufacturing design point of view, someone needs to start to leverage AI to model the complexity of different safety risks that are now becoming known, from flexible robotics, multifunctional machinery, and so on and so forth, and then mapping that against regulations as well, to kind of, because the trouble is these things are so time intensive, like there's entire industries consultants devoted to helping people design these systems, and we need to automate it. So broad, I'm not sure whether it was a good answer or not, but
yes, that's a good point. So thank you. No, it makes sense that the complexity increases, more points of failures. We need better simulations, and AI can help with that. There is one point that we wanted to cover as well, and Kate, I'm turning to you about opportunities for developing countries. What do you see the biggest quick wins are for developing countries?
So I think, one of the challenges that developing, well, there are a number of challenges, but one of the I think, biggest challenges is there isn't necessarily kind of institutional frameworks. There isn't regulatory frameworks to help organizations navigate what good looks like. But there are other ways of finding out what that is. So international management systems, so particularly ISO 45001, which is a health and safety management system. It's a best practice framework about how to manage health and safety risk. And organizations anywhere in the world can follow that. And if they're following that, they are following best practice, whether or not there is regulatory guidance or not. And I think for me, it kind of encompasses everything that the manifesto is trying to achieve in terms of thinking about what do we need to prevent harm? Yes, we can use technology. Yes, there are all these exciting, solutions which may or may not be available to developing countries. I think we often forget that developing countries might not have stable electricity. They might not have stable internet. So actually a lot of this technology is a non-starter. But a good health and safety management system, a good framework, a good process for managing your occupational health and safety, creating the right culture is a thing that's available to everyone everywhere.
Thank you so much, Katie. I think those are great points. Really running out of time. Just wanted to thank you all for all the panelists for today. I think it was really interesting. We talk about. I love your example, Seb, on listening to rocks and how we do that in a safer way. We talk about digital twins, nanotechnologies, plus AI, improving safety in warehouses, marine, manufacturing, chemical, the importance of near misses and the dangers of hallucinations, all of that great stuff. Obviously, we encourage people to go to see the manifesto, to download it. Get in touch if you have an interesting example you would like to showcase. And yeah, thank you to the panelists and thank you all for joining. We hope you found this webinar useful.
Thank you,
Have a good
everyone.
day.
Bye.